So the title of this is basically introducing students to plotting concentration response curves using Rstudio. So the students at Dundee are pretty much from the start immersed into R programming when they start the biomedical and the biological programs. And so they go through some, very basic introductory statistics. And my take on it is with the pharmacology. And what I'm going to be showing you is around a data report exercise that the students do at level 2, where this year they have taken some simulation data, okay, that they have obtained using the organ bath simulation from John Dempster's simulation suite. They normalize that, and then they plot concentration response curves using Rstudio. So, look at that. So learning objectives that they have to follow is to understand how to set up a concentration response preparation to estimate agonist potency. And that's the main emphasis of the data report. And essentially it begins to introduce them on the program to pharmacology. And they also incorporate the use of R with, to understand and analyze concentration response curves and estimate an EC50. And the reason why I've chosen the virtual organ bath or the OBSIM from John Dempster is that it gives the students a bit more work than some of the commercial simulation programs that I've seen on the market. So for example, they have to calculate the final bath concentration, and there's also more of a real-time feel to the simulation. So in the environment of COVID, particularly where the lab time was severely limited, it gives them a bit of an experience, a bit of more work to do, and then they can take that data and they can plug that into R. So I go through in the data report exercise that they have to complete some of the basics of the organ bath simulation. Now, the biomedical students will see the actual organ bath simulation at level 3. So there's a series of experiments that they do with guinea pig ileum, wet lab experiments. But for the level 2 students, this is a simulation exercise. We go through, essentially, the main components of, the theoretical lab setup, and that is important, particularly when they go into the real-time simulation. And once again, the reason why I've chosen the OBSIM is that it provides this real-time feel, which I haven't seen in many of the the commercial simulation programs on the market. So, for example, they have to calculate the final bath concentration. So they've got to then figure out, okay, what are the stock concentrations? They're presented with a range of concentrations that they have to administer. Then it's up to the students to then figure out what the final bath concentration is going to be. So they have to work out in terms of, okay, so they need the appropriate, normalize the data with the range across the range of concentrations. So they get these traces, and that's another benefit of using the OBSIM, is that from what I have seen, it closely approximates what they would get if they were in the lab, and we don't use paper chart recorders, but what they would see when they administer the drug, getting the contractions, and then seeing it on the computer screen in the lab. So they get the whole range, okay, and then they get their raw data, and then they normalize the data. Now, when you normalize the data in Excel, you can then import that into R. Now, there's two ways that you can import that in. You can import that in as a comma separated file, or particularly in the later versions of R, you can import that in as an Excel file. And to access R, so another thing is that students can get it through what we refer to as Apps Anywhere. So they log onto the university network, and then they can get access to Rstudio. There are some issues with the versions of Rstudio and the R binary. So in some cases, I've instructed the students to, if they have their own machine, to download it directly from these two websites. So the first one is where they're going to get, I've got some links there where they're going to get the latest version of the R binary, which is free, as well as Rstudio. Now, for plotting the data, I use two packages. So I use the DRC package, and I've put a hyperlink in there to the PDF, which basically describes that particular package. And there's another package that I came across when plotting the data called Magic Axis, which produces these really nice plots, particularly if you are trying to plot log data. It's particularly helpful. And as a disclaimer, I haven't had any formal training in this. Everything that I'm showing you, I have learned through trial and error. So if we go to Rstudio, okay, so if you want to get to the R binary, which is what you have to have installed on your machine, if you go to that link, that will give you the latest version of it. And they have it for Linux, they have it for Mac, and they have it for Windows. And that is particularly helpful because a large number of students are using Macs, and then there's some compatibility issues when they try to link in through the Apps Anywhere. But this gets around it. And there's also a free version of Rstudio that they can also download. And what I'm going to do is basically just get onto the R console. And so now you can do the programming directly in R by just accessing the binary, but it's very difficult, I found. And so I use the Rstudio Console to do the programming. So if you load that up, okay, you've got a number of windows, okay, and one of the first things that you're going to want to do is to import a data set. Okay, so as I said before, so once the students normalize the data in Excel, so I encourage them to do that in Excel. Now they can save that either as a comma separated file, or they can save that as an Excel file. So R will allow you to import both. So if you want to then import a data set, so you just go to, I don't know if anyone can see that, you go to environment and then import data set. Okay, and that gives you a number of options. So you can import it as a text, and this is what you would do with a tab delimited or comma delimited file, or you can import it as an Excel file. You can also import data sets from SPSS, from SAS, from Stata. I haven't tried those. We do have SPSS at Dundee, but lately I've using R, so I haven't had the need to import it from SPSS. But I often do it from Excel, so just go into Excel, and then it's a very simple function in terms of browsing, importing the file, okay, and then it should seamlessly import the Excel file in, and then if that has been successful, you'll see the data set in this window here. Okay, so I've called this DRC norm data, okay, because it's been normalized. So we have our concentrations and we have our percent Emax. And now we want to then do the analysis and then construct the plot. So one of the things that Rstudio has, which I found is really helpful, is it has this history tab. So you're not having to, hunt for code, bring it in. If you found something that works, it's really easy to keep that in the history tab. And then essentially when you get a similar data set in, it's basically going in and then using those code commands to then analyze and plot the data. So one of the things that you have to do is once you have your data set in, now I've already attached this, okay, but you have to attach your data set. So I put attached DRC norm data. Now it's going to come up with some error messages because the data set is already attached, in the console. So the next thing that we want to do, okay, when plotting this concentration response curve is to define our X, which is concentration, okay, and it's going to be specific to the label that you have in the data set. And then our percent Emax. And now we want to add our model. Now it's called model, but it could be, if you have multiple models, it could be model 1, model 2, model 3. Okay, we just have one curve here, so we're just going to call that model. Okay, and I just want to check that that's the correct one. So what I've done, this is a 4-parameter model. And what I've done, because it's normalized data, I fixed the top and bottom 0 and 100, which is important, particularly, one of the things that you'll find is that when you begin to estimate the EC50, when the students are estimating the EC50, sometimes they won't check the actual plot. Okay, so if you have the top and the bottom as variable, okay, then the EC50 could actually be off. Okay, and so the students are just going to read the EC50 from the model without actually looking at the plot. So it's one thing that is to get them to actually check the plot. But we've added that in, okay? So put the model in, okay? And then we're going to put in summary model, okay? And that will then give us our parameters. So it comes out with our EC50. Now we want to plot it, okay? So let's use the plot function. And there it plots it, okay? One of the things that I forgot to mention, okay, is that you're going to want to make sure that you have the relevant packages, okay, loaded in, okay? And that is the package tab here, okay? So I've got DRC is the package I'm going to be using along with magic axes, okay? And then sometimes you'll have to update these, okay? So these should be clicked on, okay? So I was working on this earlier today, so that's why I forgot to mention it. So now you have your plot. Now notice, okay, I've stripped out all the labels and the ticks for the X and Y axes. I've done that specifically. Once again, this is something I've learned through trial and error because I couldn't get the labels to work quite right. until I found magic axes, which is another package. So then I add, okay, why not just use raw data? Because they have to estimate the EC50, which is, the half maximal. Okay, so this is why they have to normalize it. So you could use raw data, but then you wouldn't constrain the top and the bottom. So now I'm going to put in the x-axes, ticks and labels. Okay, so I use the magic axes, so minorn. So it basically sets up the minor ticks in terms of the number, and the 1 basically refers to the x-axes. And then we want to get our y-axis, which is 2, and I've set that up as 2. So then that plots our data. You can also change, if you want, the symbols as well. So for example, if we want to change the symbol size, there's another function that you can use right here. So this CEX, okay, 1.5. So that's, once again, this is something I've learned through trial and error. So I'm able to then, change the symbol and the symbol size, and once again, put in our axes, axis labels and ticks. If you want to have multiple concentration response curves, it's fairly easy to plot them. Okay, so what you're plotting is basically a model. So we've called it model. Okay, but you could have model 1, model 2, model 3. Identifying, your X and Y, and then it's just a matter of plotting them. And you can, superimpose them, on the plot. So I'm just going to stop share. Right, okay, so you can see that, yeah, so, right, so, so once again, so you have to use the attach function to attach your data set. Okay, you need to define your X and Y. Okay, and that's based on the labels that you've set up in the data file. So I've used here the 4-parameter model, okay, and the DRC package. I've called this model, once again, you call it model 1, model 2, whatever you want to call it. And because it's normalized data, I fixed it at 0 to 100. Okay, the summary function, you summarize whether, and once again, this is whether it's model 1, model 2, we've called it model. Then that will give us the variables here, the EC50, plotting the data. Once again, use that with a combination of magic axes and the DRC, and set up your labels with XLab and YLab. Okay, so XLab for the x-axis, YLab for the y-axis, obviously. Axes faults basically strips out all the labels and the ticks. Okay, because then we're going to add those with magic axes, okay, and that will give us the minor ticks for the log axes, okay, and then add in the minor ticks for the linear y-axes, and then that will give us this fairly nice looking plot. And then if you see in terms of the EC50, which is 20 nanomolar in this case, this was a simulation of histamine. It comes out quite nicely. Once again, you'll want the students to check against the X and Y axis for the EC50. And there's probably a lot to be said to also getting them to do this paper and pencil on log paper. And I think that is about time. So that's I'm Thank you for listening.